In this video, what we're going to be looking at is we're going to be looking at this idea of limiting and excess reactants. Before we get started looking at limiting and excess reactants in the world of chemistry, let's go ahead and look at them in maybe a more familiar setting. So we're going to be looking at a recipe. So right here in front of us, what I have is a recipe, and I have this recipe for this basic, what's called a 4-ingredient peanut butter cookie. So we have our ingredients, our 1 cup of smooth peanut butter, our 3/4 a cup of sugar, 1 large egg, and 1 teaspoon. And if we mix these together, we should be able to make 15 cookies. Now, I am making as many cookies as I can because I'm going to be bringing them to school to share with a bunch of people. So, and I don't have time to go to the grocery store. So I am rummaging through my cupboards, and this is what I find that I actually have. I actually have 5 cups of peanut butter, 2 1/4 cups of sugar, 7 eggs, and 10 teaspoons of vanilla. So what I need to think about is I need to think about how many cookies can I create with these ingredients if I want to maximize. So this is what I'm going to do. I'm going to move this off to the side. And let's start with my 5 cups of peanut butter. Well, in my recipe, it says that I need 1 cup of peanut butter for 15 cookies. So if I create my ratio and create a dimensional analysis problem with this, and I know that I have 1 cup of, we'll just put PB for peanut butter, is going to be 15 cookies, what I see is that I will be able to make, what is that, 75 cookies. Awesome. Let's go ahead and do the same thing with sugar. So if I have 2 1/4 cup of sugar, well, according to my recipe, I need 3/4 cup of sugar to make 15 cookies. And if I solve this one, what I see is that I will be able to make 45 cookies. Let's continue on. I have 7 eggs, so doing the same thing. My recipe called for 1 egg would be able to make 15 cookies. So this should be able to make 105 cookies. And last but not least, I have my teaspoons of vanilla. And according to my recipe, 1 teaspoon of vanilla, put VAN for vanilla, will produce 15 cookies. So that means that with my 10 teaspoons, I should be able to make 150 cookies. Now, my question is, based off of this and based off my ingredients, how many cookies could I actually make? Well, the answer is I could actually only make 45 cookies. I can only make as much as my sugar allows me to make because that is my reactant, or excuse me, my ingredient that's going to limit my reaction. So we actually have 2 vocabulary words that we want to think about when we are talking about this. So I'm going to go ahead and clear this. And let's look at some vocabulary words when we're talking about this. So what I found out is that sugar was my limiting reactant. This is the reactant in a chemical reaction that limits how much product you can get, what you can make. And it is completely consumed. So if we go back to my recipe, my sugar is my limiting reactant. It limits how many cookies I can make. I can only make 45 cookies. And if I were to use that amount of sugar is going to be completely consumed. I'm not going to have any more sugar when I'm done baking. On the other hand, my excess reactant is the reactant in a chemical reaction that is in a greater amount than what I actually need. And when the chemical reaction has stopped, there is some of that left over. So if we go back to my recipe, my excess reactant are actually my other 3 ingredients. Because when I am done making my 45 cookies, I will still have peanut butter left over, some vanilla left over, and I will still have eggs left over. However, all of my sugar will be consumed because that is my limiting reactant. So let's go ahead and let's look at this in kind of the realm of chemistry. So here I have is a very basic chemical reaction that hopefully you guys are familiar with. So what we have right here is we have some hydrogen reacting with oxygen to form water. And in particular, if we were to look at this, what it says is that 2 moles of hydrogen plus 1 mole of oxygen will be able to produce 2 moles of water. Another way we can look at this is that 2 molecules of hydrogen plus 1 molecule of oxygen will produce 2 molecules of water. So I want to make some water. And this is what I have. Let me get all my pieces. When I look at this, I realize I have, let's see, 1, 2, 3, 4, 5, 6. So this is what I have. And my question is, how much water can I actually make based off of this? So, and if I were to think about this, in moles, let's pretend that each molecule, each one of these equals a mole. I have 1, 2, 3, 4, 5, 6 moles. So I have 6 moles of hydrogen. Over here, I have 2 moles of oxygen. So my question is, how many moles of water can I produce? Well, let's think about this. Let's do the same process that we did with our recipe, and let's do this with this reaction. So if I have 6 moles of hydrogen, according to my reaction, for every 2 moles of hydrogen, I can produce 2 moles of water. So 2 moles of hydrogen, I will be able to produce 2 moles of water. So based off of this, I should be able to produce 6 moles of water. Okay, let's do the same thing over here. I have 2 moles of oxygen. Now, for every 1 mole of oxygen, so I'm going to put my 1 mole of oxygen over here, I can produce 2 moles of water. Cross out my units. And what I see is that I will be able to produce 4 moles of water. So the maximum amount that I could produce based off of this is 4 moles of water. That is my maximum. Let me go ahead and move this up just a little bit more. So the maximum that I could produce is 4 moles of water. And why? Why is because when I react all of my oxygen, that's the maximum amount of water I can produce. If I could react all of my hydrogen, I would be able to produce 6 moles. So what we have here is what we find out is that my limiting reactant is oxygen. So I'm going to put LR for limiting reactant. That's going to limit how much I can produce. And it limits it, and it's going to get completely consumed, and I'm only going to be able to produce 4 moles of water. Therefore, hydrogen must be my excess reactant. So I'm going to go ahead and put ER for excess reactant. Now let's think about this last idea. How much of my excess reactant is going to be left over when I'm done? So let's play around with these really fast. For every 2 moles of these, it's going to react with 1 mole of oxygen, and it's going to be able to produce 2 moles of water. So there's that. So for every 2 moles, 1 mole, going to produce 2 moles. For every 2 moles, 1 mole, 2 moles. Well, how much do I have left over? Well, I'm going to have left over. Here's my excess. I'm going to put ER. I'm going to have 2 moles left over. I'm going to consume 4 moles of hydrogen, 2 moles of oxygen, and I'm going to be able to produce 4 moles of oxygen. Or excuse me, 4 moles of water. In the video that I'm going to be doing next, I'm going to be doing a more complicated chemistry problem using this for some of you guys who aren't honors chemistry who need to know a little bit more about limiting excess reactants.